Alright, sorry this video is a little late, but we're going to go through finding the rational equation from given a graph or key features. So we've done two videos about going through rational equations, how to graph them, how to keep all the key features. Now we're going to actually look at the graph and go the other way and write the equation. Alright, so let's look at our rational equation graph. Alright, so the easiest thing to start out with is figuring out where your vertical asymptotes are. So here I have what looks like a vertical asymptote at -9. So I have a vertical asymptote at x equals -9, and I have one at x equals 2. Right there. All right, so we have one at 9 and one at 2. So our vertical asymptotes are things that make our denominator 0. Okay, so as we're looking for our graph, then we put the factor. So our factor of making -9 would be x plus 9. Our factor making x equals 2 would be x minus 2. Okay, because vertical asymptotes, as we remember from the previous videos, are when we set our denominator equal to 0. Okay, so now we also have our horizontal asymptote, okay, or our non-vertical asymptote, because sometimes it can be slanted, though in this video we're not going to hit any slant asymptotes as we're looking at the graph. So our non-vertical asymptote is 0. So that tells me that the degree of the numerator has to be less than the degree of the denominator, okay? So I'm going to look for if we have any x-intercepts. So the x-intercepts will tell me if there is an x term up in our numerator. So since we have no x-intercepts, okay, and I can't tell where the y-intercept is, we're going to have to figure out what point is going to be up there. So without actually seeing a point, and here there is no major point that's going to give me, I'm just going to, we would say, so there's some constant term up there. So we have x plus 9 and then x minus 2. Okay, so because there's no specific point that they gave me, and it's hard in this graph to tell what is going on, you can put up really any constant value. So I'm just going to probably just go with a 1. All right, but it would be a non-x term, because if we were to put an x up here, we'd set the numerator equal to 0, then it's going to give us an x-intercept. Because there's an asymptote here, there is no x-intercept that's being crossed. Okay, so it allows us just to put our little 1 over x plus 9 over x minus 2. All right. All right, what if we're just given our key features of our graph? So here they just gave us a domain and a range and told us about a hole. Okay, so like we've done every other time, we're going to add the hole in last. Okay, so in the meantime, we're going to sit here and we're going to say, all right, so we have some rational function. So there's a domain. That means there's a break at -2, and there's a break at -1. So every time there's a break, so here and here, so they're either going to be a hole or an asymptote. So it's some kind of discontinuity, whether it's an infinite discontinuity being an asymptote or whether it's a removable discontinuity as a hole. So it's got to be 1. So I know that the -2 is a hole because it gave it to me. So because it didn't tell me, that means this has to be our asymptote. So x plus 1 goes in the denominator because that is our asymptote. That thing did not get factored out. Okay? All right, and then we have our range. So our range is at 2 and then at 4. So again, this is either going to be our non-vertical asymptote or it's going to be our hole. So 4 is the y value in the hole. So I know the 4 has to deal with our hole. So this 2, so our non-vertical asymptote then, so our vertical asymptote was at -1 and our non-vertical asymptote has to be at 2. Okay, so the only way to get 2 is if there is a 2x term on the top, because as we see here, then we're dividing the top and the bottom. 2x divided by x is going to give us our asymptote of 2. Okay, so now I need to use this whole to check out if we never know if there is a constant term after this, because when we divide in to figure out our non-vertical asymptotes, we're just mostly focused on the x terms. So we don't know if there's a constant term here. So what we can do is set this equal to y. This is our little function equation. So 4 would be equal to 2 times negative 2 plus c all over negative 2 plus 1. So 4 would equal negative 4 plus c, all divided by negative 1. So I get negative 4 equals negative 4 plus c, and c equals 0. So there actually isn't a constant term here. All right, so now I have 2x over x plus 1, and now I can add in my whole. So my whole is something that has been factored out. So I can add the x plus 2 in the denominator and x plus 2 into the numerator. And I just added my x value as my whole. So then this, it's the unsimplified equation that you want as an answer, okay? Because then when we're going to go backwards and graph this thing, we're going to cancel out our whole, end up getting our 2x over x plus 1, and solving everything through from that point, okay? All right, let's look at another crazy one. We'll see how crazy this is. Okay, so our x-intercepts. So x-intercepts, remember, this is going to be in the numerator of our fraction. Okay, our y-intercept was when x equals 0. Our vertical asymptotes, ooh, that looks like a 4. Helps if Mr. Lewis doesn't block it out. So we're going to say this is x equals 4, x equals negative 1, and x equals 2. So remember, our asymptotes go in the denominator. And then our whole goes into both the numerator and the denominator. So again, we're going to do our whole last. Okay, so we're going to start focusing. We've done our vertical asymptotes first each time, so let's start those first. So here we have our, I'm going to use a bigger denominator. So we have x minus 4, x plus 1, and x, minus 2. Okay. So there are my asymptotes. It doesn't tell me anything about a non-vertical asymptote, so I'm just going to assume that everything in the top is going to be told with me by these x-intercepts here. So in order to get x-intercepts of 3, that means that x minus 3 is in the numerator and x plus 2 is in the numerator. All right, so now we need to check for an a value to make sure that our y-intercept would be negative 3/4. Okay, so negative 3/4 has to equal this if I plug in 0 for x. So 0 minus 3 times 0 plus 2 over 0 minus 4 over 0 plus 1 over 0 minus 2. So here I get 3/4 equals, on the top here I get negative 6, on the bottom I get negative 4 times 1 times negative 2, so that is 8, and negative 6/8 is the same thing as negative 3/4. So we almost got it. We just looks like there is a negative term in front of it. So there needs to be a negative up in my equation, okay? And then now that I have, so y equals, here is my whole equation. So now I just need to make sure that I plug in my whole. So x minus 1 and x minus 1 goes in the numerator and the denominator. So here would be my equation. Oh, I'm sorry, this was supposed to equal negative 3/4. So, actually, this is just going to be plus 1. Okay, make that positive. I'm sorry, this was supposed to be equal to negative. I forgot to carry it through. So, actually, we did not need any a value. So, this is actually our whole equation right there. All right, so hopefully this kind of helps work through from our key features on our graph. It's just, this unit is one that you just need to be very, very careful on. All right, so watch as we're going through there, and definitely look to your teachers with any questions as our test is coming up in a couple of days. All right, see you guys later.